Looks like that. Very simple. All this code is available on GitHub if you want to look at it, or how to run or play with it or play with bits and put some issues in GitHub that can point out on our phone tips. But basically we've got some locals. We've got a document that defines what the Lambda is allowed to do. In this case, we're allowing Lambda to assume a role. We're going to tell it that it can run, we're going to specify some code, and then we're going to run. Tagging policies, and if you do commit ID, tag things, maybe. Is the code version identifiable and retrievable for analysis? And by that, I don't know, logging into Lambda console and see download zip file. It's not really, is it? You can't, it's no reusable artifact, you can't promote code from dev to UAT to production without something going in and checking and adding something. And you have to rebuild that code again every time. Not really good. And if we listen very carefully, we can hear someone say in the comment, oh, what's a Lambda? Which we don't want in cloud. Is the function code deployable every time the runs are on? Yeah. We'll see. If the project is small and you've not got any CI, CD workflows and someone's running Terraform from a laptop, probably. But if we've got any sort of CI and your archives are getting built each time, even file everything zip pipe stuff is not going to work particularly well consistently. The result of zip files may have different checksums depending on how you build them, what versions of zip things are running, which we will dig into in a little bit. That's the question. So have a look at where we can go from the basics. So the next one is we start introducing a little bit more thought and logic into what we do. So we're going to step into the shell scripting sanctuary this time. And we're going to look at some tools for bundling zip files and how they experience how many version artifacts. We're going to do, well, Terraform has an archive file thing, but it doesn't support multiple directories. So if you need like a common library, which everybody does, you can't call it shared, but you might call it something else. For everyone's Lambda has a shared library. Usually it's going to be logging functionalities or some sort of business logic. So we can shove a nice little shell script in there that we can run, and all we're going to do is just pop into a directory, zip some stuff up, and then dump it in a single bucket. Not bad. We're going to decouple the responsibility of packaging our code and then also deploying the code. To step in the direction to a slightly more complex way of doing things, where we're not relying on a single tool for doing our whole end-to-end workflow. What it looks like it's remarkably similar. Remarkably similar, but this time further down the bottom, we're now looking at an AWS object. We're looking at an AWS object rather than a locally zipped thing. So we'll get a bit closer to artifacts that we can identify. Nice. And can we identify them? Well, there's a little helper script here, and all it does is it will go and look at all the objects in your Lambda bucket, and it will tell you the versions, the commit IDs, and the hash, which means we can now identify what version of code is deployed where, when, and how, which meets some of our criteria. That's fantastic. So is the code version local, cycle? Is the code packaging handled in a way that creates artifacts? They're now targetable by ID, which is nice. Can we find the right one and figure out when it was deployed and how it was built? Yeah. So in the Lambda console, there'll be this hash, right? And with that little script there to look at, we can see the version ID, the commit ID, and the hash, so we can tie it all together, and we know what commit produced what artifacts and when it was deployed. So we start retrieving stuff. Dead easy. Will it be deployed every time the IIC runs? Learning code should mean that there are no new deployments for this way, right? However, I discovered during this that zip files have some interesting challenges. So we're going to do a badly timed segue into the zip shop. There's no treacherous or anything like that. It turns out the spec for creating zip files includes a number of headers which get in the way of the whole deploy it because it hasn't changed thing. Specifically, last file modification time and last modification date become problematic for us. You can see down there the table that I pulled straight out of Wikipedia without having to rewrite. But mainly we've got file, last modification time, some bytes and some offsets, and then down at the bottom is what this artifact looks like in hex editor. I'm really bad at that. So you take that one and that one and you flip them around and you do some stuff. Thankfully, whatever the educational site was provided the instructions on how to do that. But you can take the things that you pull out there, do that, change the date, and you can find out what time what is set again. Lunchtime. And you say the date, you take the next two, you jump around, and you get the exact date and the time. It's in DOS format, so it's from 1980 plus number of years, which is fun. But that means that if we create a zip file and we create a zip file a few seconds later, that zip file is a different zip file, even though the contents of it are identical. That's not helpful when we want to say only one of those is changed, because every time zip file is changed. That's not correct. However, Terraform's zip thing uses the Go outbound zip library. Apparently, that just kind of ignores the whole thing and never specifies it, so you do kind of mostly often get the consistently produced package. Now, I run this in a number of different operating systems, a number of different CI things, and I could not get consistent delivery for it. It's fairly consistent. When it goes into some of the file, often do get consistent. So that's really good. With your anyway. So given we can have a packaging script to do the make sure it gets through, why don't we just get Terraform to package it for us and run the script directly? No, don't do that. That's awful. Bad behavior. Welcome to the fancy zone. Terraform is a declarative language, and doing sort of if something exists, do this, or if it doesn't, then do that is imperative logic. Terraform does not like that. Please don't do that. And if you are doing that, stop it. It is very, very bad job doing. It can sort of be forced into compliance through creative uses of data and null and external things. But at that point, you probably stop running that yourself just because you can, should you? No, you should not. If we've already got function S3, well, we can do it, but then you've got this logic at the side where is the thing S3? Yeah, it's great, use that. If it's not, then run the script and package it. Or you have to run the script and package it every single time, and then that breaks when it. Again, you can be creative in that and make it work, but should you? Probably not. This is where we start to get into patterns that really we should be thinking about in production systems that have got decent sort of level users and change happening. So we're going to explore the major mechanics where Terraform is defined a little bit more. There's also harmonious balance between code bundles and commit IDs. We can't technically do those final point. The mesmerizing dance of versioning without undue deployments. So it looks quite simple, yeah. We're kind of back to the second one we saw a little bit, where there's Terraform, some files, buckets, lambdas and stuff. So we're going to go back to using the archive file resource again. Similar to that very first example, the copy and paste one. But instead of letting Terraform handle the whole packaging and the deployment, we're actually now going to tell Terraform to package the code up, stick it in S3, and then with a little bit of logic in there, we can actually make the Lambda's resource, the source code cache thing, use the git commit ID from the branch that we're currently on. So instead of relying on the package, we're relying on the commit that the code is deployed from. So we don't result in artifact deployments unless we're in the commits, and that way all can tie together and becomes more identifiable. Goes like this. So the major differences are we've now got this external call to git to find out what the commit ID we are currently working with. And then again we've just got an archive file for Lambda where we package stuff up, and then we've got an S3 object that gets created now. And then you can see in the Lambda we've got this horrible one Beneficiary statement that is, if the object's metadata that we commit that we're currently working on matches what we're currently working on, all it's override everything, then update the file. And that way we get a little bit of artifacts deployed constantly, unless we want that to happen. And it means that our deployments are dependent on new stuff being published. And it all ties together much nicer without having to do any imperative estimates. But in, you see, we have a shared library that is packaged with our Lambda code. The archive file directory, so if you've already told us can't do multiple directories, how are we going to solve that? What a very timely question, thank you. By combining a little bit of options 1 and 4 and some of the process and the kind of layers to option 3 without stepping into the imperative thing, we can invoke a packaging script through Terraform, but we can keep everything declarative. So we can always do it, but now we've got that upload mechanism that handles the whole if this thing that kind of thing for us. We can introduce a packaging script that's responsible for staging our code somewhere, and then the Lambda and our sort of shared common, whatever you want to call it, stuff we say. It's looking a little more complicated than the resource graph, but it's still like 7 boxes, and the combination of that. So we need a packaging script. So here is one. Maybe don't design production, but it's kind of there. We have a target function that we pass in. We have a staging directory. We shuffle the staging directory around to make sure it doesn't contain any stuff. And then we just copy our Lambda in, ignoring any cache, copy the common or share or whatever you want to call it in there, zip the whole thing up. And then because we're using we're using an external to run this, it does expect it to be a JSON output, and it's using this at the end. And then it will run every time. And we're using externals because externals run on plan and apply, whereas no resources only happen on apply. And that means it runs every time consistently for us, and we can test and check every stage of the workflow. And then at the bottom you can see basically the same thing again, because we're already expecting to use our code from S3 bucket, and so there's no change in that part of how we're going to deploy code. Does that follow rules then? So is it version compatible? Yeah, it's identifiable, it's type, it's version. Making promotion for environments now is really simple, and it's auditable because it's all done by the commit ID. If you put a tag on there or you branch from it for the release, all that is now consistent across environments. Is the code version identifiable and retrievable? Very, very easily. In fact, we show the script to do exactly that. We can identify what the version of code is, we can identify the artifact that built it, and then we've got this metadata for tracking things for the code. Really, really easy now. Will the function code be deployed every time? Nope. Only when the deployment is from a new commit ID will the code be deployed, which is exactly the thing we want. I did include a way in there as a developer. I don't have to put my code in commit every time I have a print statement because I feel like what an object looks like. You can just override that behavior, so it always forces a new thing out. Best of both worlds, really. And then the last one. So now we're seeing a couple of the options that we've got elsewhere. How do we put that together in something that we can run at a very, very large scale platform where we've got considerations and it's not just one team building everything. We're going to enter the empowerment enclave. Experience triumphant symphony of deployment workflows in the empowering enclave. I might like to do the rest of it. So now we're going to step away from kind of Terraforming everything. We're going to go back to that kind of letting a packaging script do our packaging. We're going to also have a deployment script on the end, which does the deployment of the code. And then we're going to let Terraform build infrastructure and not build full code pipelines. What does that look like in practice? So, a particularly large and mature environment, I'm not suggesting every project should look like this, but you're going to start going down the road where code packaging, code deployment, and code release are not the same thing. You don't want to do full infrastructure deployments just because you change types of code base. You want a dedicated code packaging workflow, so you can build test package and upload artifacts in one work stream, like a completely separate repo, We've got dedicated infrastructure as code workflows, so we can apply and test if you deploy. they will deploy a placeholder function, so it's like a hello world kind of thing. And then we have a separate dedicated workflow for releasing the artifacts produced in the top one, the infrastructure in the second one, which allows us to do great sort of business logic we need, whether it's triggering from ServiceNow or some sort of service catalog. We can identify a code that we built there. We can deploy it. We can do it through AD, we can do it through Ruby, Canary, any other workflow you like, something that code deploy supports, for instance. What does that look like? Well, we need to build a function. So we've already seen the script in the section. We're going to build some code, we're going to package up some code, and I'm going to stage some code first. And then we need a script to deploy the code. Absolutely as simple. Here is it using just the Lambda update code function. We do it three things: function name, the object name, and the bucket that the object lives in, which was produced by the script. And then we have some Terraform to deploy. That's simple. The main thing here is the archive file that Terraform now thinks it's going to load is an incredibly simple one handler and a print statement. That's it. It doesn't actually do anything. So until you build the code, deploy the infrastructure, and then update the function code, it's just in a good state, which is perfect for that sort of situation. It means that this never changes and it will never try and override the function. You can see there that we just ignore the source code hash, or ignore the last modification date, because we've completely decoupled those three parts of our workflow. Does that work better for us? Well, the function code is absolutely versionable, promotable, targetable, because it's all now separated with its own discrete things that care about stuff. It gives us an absolute amount of control for what's released, where, when, how, why, and what. Can we identify stuff? Well, from separating that packaging and deployment thing, we have to have a really accurate identification mechanism. So by that, yeah, we've had to have one, so it works. Therefore, will function code be deployed every time our ISE pipeline runs? Well, no, because ISE is no longer responsible for packaging and managing that code. Who's there? So what did we learn? Well, formatting that deck took a lot longer than I was expecting to. And ultimately, do what you want. But importantly, you need to think about it first. If you think about option 3, maybe that's not a lot. But just think about what you're doing. If you're building everything with Terraform, maybe that's a great way of starting off the project. If you're expecting to get to a thing where you know there is a spike and you're going to ramp out to 4 teams, maybe it's not the right way of doing it, because all the teams are responsible for various things, and you don't want everyone fighting over the same bits of the project, no matter how good the production strategy is. So depending on the size of the project, you need to make appropriate decisions. You can't predict the future, you can't predict how much a project will grow, or the size that things are going to run at when it's all in production, but you can avoid backing yourself into corners through your own choice of, I'll do that later. Having a plan for where to go is important. I ran some of the numbers on, say, files and build times, and there was absolutely nothing in it building. Obviously, build that. There's nothing in it for build time, there's nothing in it for file size, really. The important thing is making sensible architectural decisions when you're doing it and knowing what options are available to you as an engineer. There's a QR code with full examples at the bottom if you want to look. And that's kind of it. Well, thank you very much for joining me this morning. I hope that was interesting. So has anyone got any questions at all on any of the things in there other than the artwork? Any questions at all? Yeah, Lambda layers are their own special thing. The easiest way I've found to do it has been through Docker. So having a container running the build time of sort of Node.js or Python, whatever, have that build a zip file of all dependencies, so it's install, freeze it, and then zip everything together, and then you upload those. There is both Docker a provider for Terraform, so you can put it in there, you can be decoupled, or you can actually make Terraform build dependencies for you. What we found with building dependencies like Terraform is if you've got people with things like an ARM chipset and people with an x86 chipset, some people can't really build something. But I mean, pushing into CI is no longer a problem. Having it decoupled into something like a container, so you know it's consistent. And then if you decide to switch to something like Graviton or ARM-based Lambdas, it's quite easy to just change that build rather than do it on your laptop or change all your CI runners, for instance. You can emulate it quite nicely. Anybody else? Jonathan, you can help.
Thank you very much, Aiden. You are more than welcome to stay for more coffee and pastries and stuff. And to chat to Aiden without being in the glare of everyone asking questions. But yes, thank you very much for coming. And I'd like to see you again next month, which will be the third Wednesday, as usual. So, thank you. 19th, yes. Cool, thank you very much.
Yep.